Today's topic is electrochemical series of electrochemistry. Electrochemical series is a series of electrode potentials and corresponding half cells is called as electrochemical series. That means if you write the electrode potentials as well as the electrodes and their half cell reactions in an order, the electrochemical series will be formed. Here, let us know some fundamentals regarding this. The difference between standard electrode potentials of electrodes of an electrochemical cell is called as cell potential or electromotive force. It is abbreviated as EMF. I am repeating again, the difference between standard electrode potentials of electrodes of electrochemical cell is called as cell potential or electromotive force. Now let us see what is standard electrode potential. Potential difference between atom and its ion when they are in contact is called standard electrode potential. So I am repeating this point again. Potential difference between atom and its ion in contact is called standard electrode potentials. Next, another important thing is I am repeating the definition of electrochemical series again here. A series of electrode potentials and corresponding half cells is called electrochemical series. Standard electrode potential of element may be expressed as either standard oxidation potential or standard reduction potential. Each and every element has these potentials. Let us see the important example here is given. Standard oxidation potential of zinc is 0.763 volts. And the zinc also have standard reduction potential, but it can be represented as minus 0.763 volts. Okay, have you understand this? Here the values are same, sign conventions are changing. Each and every element have these two potentials, that is oxidation potential or reduction potential. Here the conventions considered while forming electrochemical series. As we know that each and every metal or each and every element will have standard oxidation potential as well as standard reduction potential. But here, according to IUPAC, the considered convention is the reduction of reactions. So, in electrochemical series present or given in our books or with respect to standard reduction potentials of the elements. This series indicates the tendencies of electrodes to behave as cathode towards standard hydrogen electrode, which is abbreviated as SHE. If electrode potential, that means standard reduction electrode potential of an element is less than zero point 0.0 volts, Then the electrode acts as anode when it is connected with the standard hydrogen electrode. It is very important, I am repeating again. If standard reduction electrode potential of an element is less than zero point zero volts, it works as anode when it is connected to standard hydrogen electrode. If standard reduction electrode potential is greater than zero point zero volts, then the electrode acts as cathode when it is connected with standard hydrogen electrode. So let us see by taking one example. As we know that in previous learning, the standard reduction electrode potential of zinc is minus 0.76 volts. It is less than zero point zero volts. So zinc acts as anode when connected with standard hydrogen electrode. Let us see another example, copper. Copper has standard reduction electrode potential as 0.34 volts plus 0.34 volts. We know that it is greater than zero point zero volts. So copper acts as cathode when it is connected to standard hydrogen electrode. Applications of electrochemical series. Based on electrochemical series, the following will become easy for a chemist or physicist. It is useful to predict the spontaneity of redox reaction, and it is useful to construct an electrochemical cell. It is useful to know the reactivity of an element. It is useful to know the strength of oxidizing agent as well as reducing agent. Here let us consider one example. We know that standard reduction potential of zinc is minus 0.76 volts. That means it can give electrons easily. So it is strong reducing agent. Let us see when copper. If you want to remove electrons from copper, you have to apply plus 0.34 volts of current. So it is weak reducing agent. So by means of that, we can apply electrochemical series. I am repeating again the uses of electrochemical series. It is useful to predict the spontaneity of redox reaction, useful to construct an electrochemical cell, to know the reactivity of an element, to know the strength of oxidizing as well as reducing agent. Thank you. Happy learning.